we're going to kick this off, deploy, release, CI/CD, oh my, DevOps for the rest of us, and was definitely challenged by Homer yesterday. So because of a big room like this in our screens, I'm going to, if you want to follow along, this is a great link, bit.ly, viewconf-2022, and you'll be set with, be able to follow along. You'll have actually more slides because it's true to those of us that tend to speak a lot. I was changing my slides 8 minutes ago. So, it'll be a little different, but that's all right. I mean, that's just what we do. So, all right, so we're going to jump into this. Well, it seems that every week there are constantly new terms that kind of come out. We have, describing different DevOps tools, different segments, different ideas, practices. Are any of these terms, are they really new? You have CI/CD and progressive delivery and AIOps and GitOps and MLOps and TreeOps. And okay, so TreeOps isn't actually one of those, but the rate we're going, it may be next week. And I do want to kind of have a side note that when I started building this talk, I literally registered devtreeops.com and treeops.cloud, which both of those are currently coming soonish, which is also a DevOps term, soonish. But that also means I have over 25 different domains that are sitting there doing nothing. Hi, I'm Jeremy Meese. I have a problem. I've spent over 27 years working in tech. Yes, I did start when I was 3 years old. And I've covered just about every functional area in an IT department, everything from support to system admin, to app developer, program manager, project manager, systems analyst, network admin, janitor, maybe not that one, but I have spent also the last 10 years heavily involved in DevRel and community. And if you want to know about any of those that I mentioned previously, you can come and talk to me, or we can talk about DevRel and community over many beers, or whatever your libation might be. So with all these terms that are out there, are there any that, are they all just the same? Or are they kind of just reimagining last week's buzzwords? And sometimes it feels like companies, they kind of throw, they like to chop up a lot of these different buzzwords, put them all in together, throw them into a salad, and boom, they have a whole new term. So first, we're going to talk about what is DevOps. Let's kind of set the stage here. For those, I saw a large number that kind of raised their hand. So hopefully, I will answer that for you. DevOps is kind of a technical kind of definition here. It's this union of people, process, and technology to kind of continually provide value to customers and to the business. It's about culture first, not the tooling. Patrick Dubois, who is one of the creators of the term and of DevOps Days itself, describes DevOps in this way. He says it's everything you do to overcome the friction that's created by silos in your business, and then all the rest of that is just plain engineering. So that's why it's about culture first before it becomes about any of the tech, any of the tooling, any of the different TreeOps domains you want to register. Another good friend, Matt Stratton, says that you can't buy DevOps, but he'll be more than happy to sell it to you. So if you want to just go out and buy the DevOps, contact Matt Stratton at Matty Stratton on Twitter. So as we think about the DevOps lifecycle, there's kind of the hope of how we implement it, and then there's kind of really the reality. John Allspaw, who's again kind of one of the early works around continuous integration, continuous deployment, and DevOps, he called it kind of work as imagined versus work as done. In this tweet, which was about a little over 6 years ago, it does describe a lot of the development that I tend to do. I think I'm going to do it one way, and then I get stuck in the swimming in the pool there at the bottom. We call about the hope and the reality. We again have the hope of how we're going to do things. The reality is then we get caught getting a call from recruiters. We also argue with developers. We try and deploy. Next thing you know, we are stuck again talking to different developers and hoping to take another call from a recruiter. So that's kind of how we kind of find ourselves in. So what I want to do here is really break down some of the more recent terms that are out there that you might have heard, help you understand what those are, and then we'll spend the last 45 minutes of the talk talking about continuous integration and continuous deployment. I heard no chuckles there. So I guess since you didn't challenge me on the next 45 minutes, we're going to be here. I mean, it's me and holding you to the break. So I got the clicker and everything else up here. So GitOps, we're going to start with that one. This one's relatively new. It has, there isn't even a Wikipedia page for it. I've been doing this, and giving this talk a few times. No one in the audience has decided to go and create a GitOps page on Wikipedia, so that probably tells you how viable the term actually is. Hopefully no one here works in GitOps to challenge me on that. Now, it does kind of pull in when you go search for it. You can actually find it as a subset of the actual DevOps page. But even then, it's like a sentence, which again, it's probably not as important. But I feel like since there's not a page, it's probably a serious oversight by the DevOps gods, and that one of them at some point should probably kind of rectify it. At some point, it will probably be one of these three. So, Weaveworks, who's a company, a DevOps company, they coined the phrase. So again, you coin the phrase, you get to describe it. So they call it a way to do Kubernetes cluster management and application delivery by using Git as a single source of truth for declarative infrastructure and applications. Hopefully you all followed along. You'll be able to answer all these questions later. And it kind of attempts to take this idea of continuous delivery and infrastructure as code. I know those are two buzzwords. And we can talk about those later. But those principles are non-tool specific. They're not really around any tools. It's about their principles, their process, and ideas. And so this idea of GitOps kind of tries to take in those principles and repackage them down into tool-specific activities, which kind of goes against a lot of the ideas of what we think about with DevOps. And as I've seen it over the years, this term never ceases to carry its own weight of controversy on DevOps Twitter, and there's probably DevOps TikTok you could also put there. So if you want to, like me, start a fire and then walk away and just watch it burn, feel free to just ask, what is #GitOps? And then just sit back and grab the popcorn. DevSecOps. So this one, Phil Richards, a post on ThreatPost, say that 6 times, puts security at the forefront of the development process as a whole, ensuring that good cyber hygiene remains top of mind for developers and operators from start to finish. It's also, on Wikipedia, they kind of get a little bit more talk about, it's just this augmentation of DevOps that allows for security practices to be integrated into the whole DevOps approach. So each delivery team, so that's everybody on the delivery team, is empowered to factor in the correct security controls into the software delivery process. So security practices and testing are performed earlier in the development lifecycle. It's kind of hence the term, you've probably heard shift left. The idea of, that phrase is really about, making sure that it's shifting it more towards the center and more towards, earlier in that whole process. Not that it's shifting it onto developers when you think about DevOps. It's literally about shifting it more to earlier in the process. You're thinking about security and how that's going to impact, how that's going to impact your application, whatever it is you're building. So there are many tools out there that kind of give developers the resources that they need and the power to kind of implement security as an important part of that life cycle, and not just kind of as this afterthought that you kind of throw it up over the cubicle or the remote Zoom wall or wherever it might be. Now, progressive delivery. This is something that is, again, relatively new, that's kind of out there, kind of fits within software development kind of life cycle. It's a newer term. It was coined by James Governor of RedMonk, who said that it's this continuous delivery with fine-grained control over the blast radius. Another way to kind of look at that is that there's this idea of continually, let me go back actually. So there's this idea of feature rollouts in feature management that kind of gives teams the ability to kind of use this progressive delivery model that kind of defined by like dark launches and feature flags, testing in production, which keynote, everybody tests in production, whether they admit it or not. Every time you deploy, it's a test in production, hoping that it's going to work. So we just have that hot take. We all test in production. Continuing on, canary launches, blue-green deployments, A/B testing, all of those are kind of this idea of feature flagging and kind of progressive delivery. So when we think about the progressive delivery way of doing things, there's kind of two tenets that kind of make this up, this methodology. So the first is like release progression. And that refers to kind of adjusting the number of users that are impacted by and even exposed to the new features that you're rolling out. And it's doing so at a pace that's really appropriate to your business. You can perform kind of these release progressions in a variety of different ways. Like you can target rollouts to just these subset of users. You can, do canary launches to see if something breaks. Percentage rollouts, so just the 10% of the users, and just progressive. And there's many different ways to do this. And you can also kind of think of kind of release progression as kind of this progressive deployment or a progressive release. The second piece, though, is this progressive delegation. This refers to kind of progressively delegating control of the feature that's being developed to the owner who's most closely responsible for that outcome. So if you think about it, when you're developing the different controls for a web page, if that's just your piece, or you're responsible for the entire web application, that's your responsibility there. But once you've finished that feature, now you are, and it's building and it's testing and it's working, you turn that over, and it's the responsibility of, say, the product manager to actually get it released, get it launched. And then you can go back to doing what you really want to do, and that is develop. Now, I've used the words release and deploy. Over the years, a lot of IT professionals have kind of gotten these mixed up and kind of confused these. And there's actually a big difference. And so, I'm going to kind of break these down real quick, and then we'll go into the final pieces around like continuous delivery and continuous integration. So deploy. A deployment is, that includes all of the technical activities that are needed to make a software system or a feature or the application available for use. So if we think about in the terms of like architecture, like a Docker container that's running in a pod on a Kubernetes cluster, it's passed all the tests that it's in the pipeline, meaning that it's working. It's now ready to receive traffic, but it's not. But that's not been turned on yet for production traffic. So it's ready, waiting, but nothing is coming towards it. It's been deployed. This is really just to make sure that the new system is ready, it's running smoothly before you start introducing kind of the production traffic to it. So when you think about deploying a piece of software, it is, or it should be, a very mundane and risk-free process, risk-free activity. And it's kind of related to the overall continuous delivery process, but it does tend to be more automated than just this kind of manual way of deploying or releasing software the way we used to. Now, when we think about release, this is going to come after deployment, and that's going to include all of the activities that are needed to move part of or all of production traffic to that now deployed new version. So all of the risks that could go wrong, so like downtime, lost revenue, bad customer experience, sleepless nights, all of that comes in with the release, not the deployment. So that's where releasing software really has got to come, be thought of as more of like this slow, very methodical approach, because that's where you're introducing all of the risks to your business and to your customers. A release cycle, it's really that overall process of deploying software to an environment and then ensuring all the deployments in the release are functioning and performing as expected. And this is where it practices like progressive delivery or release orchestration, which is kind of a newer term that's coming up, and it's really about getting all of the things ready so that you can release comes in. That's where you assign like version tags and such. All right. So now the real meat of it, and this is what I really love talking about, is continuous integration and continuous deployment. So this is rooted very much in agile methodologies. And it embodies kind of the culture of a team or a company's commitment to automation and DevOps principles. Agile methodologies generally contain kind of this set of operating principles. If you ever are looking for great reading material when you are, on the Porcelain God, or have nothing else better to do in life, read the Agile Manifesto. It's based on 12 operating principles and kind of this collection of practices which enable dev teams to release quality code more frequently and reliably. That's really the idea of agile development. Those principles then brought about a lot of different agile software development frameworks. So things like lean software development's on that list. Kanban, Scrum, everyone's favorite casserole, Scrumban is on that list too. So who doesn't want a big hyping plate of Scrumban? And then it's also brought about a lot of different agile software development practices. So there's fun ones in there. There's one called the planning poker, which I actually have no idea what it is. I did not want to go and search it to pollute my Google search history. So that's for you to do. I'm not going to do it. But one of the things that came out of the agile movement, as I briefly mentioned, it's on this list, is continuous integration. The main contributor to that was this guy by the name of Grady Booch. Anybody ever heard of that name, Grady Booch? Okay, yeah. So some of us that have been around, 27 years means you also were 3 or 4, maybe 5, 6. We'll go. Are familiar with that guy. So Grady Booch, he's still around. He's also one of the originators of the object-oriented kind of way of programming and the founder of UML. First proposed this idea of CI in 1991 in his book, Object-Oriented Analysis and Design with Applications. That method advocated for, kind of more of this frequent use of classes and objects in programming in order to simplify the design. Prior to that, we didn't use that. His version of CI didn't suggest releasing multiple times per day, though. That came along in 97, which was kind of this idea that built on the Booch method called extreme programming. I'm sure some of us have heard of that one. I even had that book. And that was the kind of the whole crux of extreme programming, was taking all of these already standardized concepts for how we wrote and delivered software, and then went way further with those concepts. Hence the really unique way of saying to the extreme, why it's called extreme programming. This kind of brought on kind of these shorter release cycles, started to be kind of taught a lot more. Extensive code reviews, which we now kind of think about as pair programming, unit testing, acceptance testing, all those things kind of came about as a result of extreme programming. And this is where we kind of got a lot more methodologies that kind of built up on that. And all of those were just about writing cleaner, more higher quality code, and then getting it out quicker to the users. While we recognized that all that needed to happen, we didn't really have tools available to do so. It was kind of something we had to do really manually until 2001 when Cruise Control came out. It was an open source tool. It was the first one that kind of made this continuous integration easier to achieve. And compared to kind of what we see today, it was very primitive and prehistoric, but a lot has changed in the last 21 years. But back then it was a game changer. It was really revolutionary. We had, this first time again, it was a system that you could install, stand up in your data center or underneath your desk. And it would allow you to kind of help manage your software process, release way more often. You could even integrate it with your IDE. You would have to have a kind of a specific specific variant for it. So if your IDE was Eclipse, you had a Java-specific variant of Cruise Control and so on. Eventually, it was overtaken by Hudson, which is probably a little closer to some of you recognize the name Hudson, which then became Jenkins, which is still very widely used today. It supports a lot of different languages. It can be made to do just about anything you want. It has an enormous community around it. So when you run into difficulties, chances are somebody else probably has too, and they've created some way to get around it, which is kind of the upside for something that's been around that long and has been pretty popular. It's still relatively stable. kind of secure, depending on what you're doing. The downside is that, we've kind of moved away from, the way we build software to, and even the way we deploy it. And it's the way we use software is changing. And Jenkins is still kind of showing its age. You kind of have to spin it. You have to. It's not kind of. You have to spin up your own infrastructure. Have a team that's managing that, and that just doesn't. It's not really how we do software nowadays. And so that we've seen a lot more things move to the cloud. Companies like Circle CI and others. There's a lot of them out there. They really exist and built to kind of help babysit that process for you, so that you don't have to. So they do the service, they handle this infrastructure, and let you get back to the business of writing software. They're going to support pretty much all the languages, all the different resource classes, the build environments, having experience to deal with the Docker and the Kubernetes that you probably don't. And it's probably not your business to try and learn that. You want to be doing, for some of you, front-end development or the full stack, but yet, you don't need to run your own environment. So letting cloud services do that is really kind of, it's both more flexible and lower maintenance. Many years ago, thankfully, Microsoft had this thing called Visual Source Safe. Who here has used Visual Source Safe? Who regrets most of those days in life? Yes, all of you. Yeah. In theory, it was good. I mean, it worked. It did when it came out. It was what we needed. The idea was that you would check out or lock a file that you're working on so that no one else was working on it, and that way you knew that you couldn't overwrite it. You could push your changes up and then unlock it. And now you could do some testing and see if it worked. That usually kind of devolved though into, when you're trying to do work, hunting around for that developer that happened to lock the entire directory instead of just that one file, only to find out that they had gone on vacation for 3 weeks, and then you had to submit a ticket to IT, which also probably, oddly enough, took 3 weeks. And so nothing really happened. That was kind of my experience. I think it was often experienced by everyone else. So it kind of, the way, loss of productivity. So when things got down to, merging in the code base, when you got to the QA testing piece, that's really where a lot of the problems came in, is because everybody was doing lots of different things. And so things get locked and wouldn't work. But there is a better way. So continuous integration. That's the practice of merging all developers' working copies to a shared code repository. It's identified as, you're merging code changes often, so the team is more informed about what's going on, what each other's code base looks like. And then code base changes are merged often. You're able to run automated tests to validate those builds, making sure that you're merging high quality code and you're not pushing bad code upstream. And you're also only integrating that tested code in the code base. And then making sure that when these changes are merged, that they're frequently released to a production branch or maybe a release branch, depending on how your team works. The term fail fast and fail often is an important one when we think about continuous integration. And it does give development teams the ability to know when stuff is broken, which is invaluable. If you're working on a set of code and you have not pushed it up and done any testing against your main code base in 2 weeks, 3 weeks, a lot of things can change, and you can introduce a lot of breaking changes and a lot of inconsistency into your code base. So it's important, like continuous integration kind of gets us a speed in a sense that allows us to push things up, the automation take over, test, and you can get back to continue to work on those features and with the confidence that what you're building is actually working. Now, continuous deployment, excuse me, is basically, it's just automation. The goals of CD and producing software releases is generally going to be that automation, efficiency, reliability, reproducibility, and verification of quality through continuous testing. In the way we think about that is kind of as a pipeline where you're releasing software faster by automatically getting all of those source code changes, running them through that building, testing, packaging, and other related operations that are needed to kind of get to that release. In most cases, it also means that you're delivering smarter and lowering the risk to your release process. The code and software that's being released is of higher quality because, again, you know it's tested. And then you can also lower your costs. You're not having to deal with the time spent at trying to deliver software to multiple infrastructures like staging, QA, and whatnot. You can automate that through the continuous deployment process. So you may ask, is CI/CD a tool? And in the spirit of every answer to every DevOps question, and I think actually the answer was kind of stolen by Austin a little bit, it depends. It really does. Much has changed in the way that we as developers kind of build and ship code. So when you're implementing CI/CD, you're really implementing practices and principles which aren't about the tooling. Yes, there are tools out there that enable you to do it, but before you get there, you have to, you and your teams have to sit down, decide how you're going to implement those, and those practices and principles. You don't want to go too big at once. You want to make sure that try a little a sample project to see how your teams can work and figure out what works for you. Because CI/CD aims to really break down the walls between dev and ops and get everyone on the same page working together. Instead of just throwing things over the wall, you're all kind of breaking through the wall here like Kool-Aid Man and working together. You don't have to implement it all at once. So kind of think about even the way of implementing CI/CD as being iterative in and of itself. So understanding those systems and the tech that's currently in place in your organization, combined with the culture, which itself might have to be changed and adjusted before you can even get to deploying anything in the DevOps realm. You dramatically influences kind of the customization that needs to happen to implement. So, the fundamental tenet of CI/CD is really, it's quite simple. Committing and integrating your code often, daily at a minimum. It's important. Such a small change in kind of your software development process can really yield a lot of big results. When we're committing more often, we're identifying, resolving merged conflicts earlier, or we're probably avoiding them altogether. So instead of writing 1,000 lines of code and finding an error, you're only maybe written 100, which is a lot easier to test. You're able to get code out there quicker to your audience, to your market, figure out if it works, if it's good for the market fit. You can get faster ROI. You can also, get higher, be more sure of higher quality, more stable code, and then that translates to your products. And then your customers get access to new features faster, which can increase customer satisfaction. Also can help you to kind of test out new things and see if it works. And if it doesn't, you can pivot instead of spending 6 months on a project only to find out that nobody really wanted that widget you built. And then also keeping devs happy and shipping code. Like, much rather code and get it out of the way and go on to the next fun thing instead of sitting here waiting. So, we think about speed. This is the obligatory Top Gun gift that you always have to give whenever somebody says, hey, we want speed. So I feel the need for speed. CI/CD really enables you to, feel like Maverick and less like Goose because he kind of, dies. So really, you want to be more like Maverick in that case, and get to amazing speeds as a business and become a high-performing team. It's important to when you have a high-performing team, much like these, who I'm going to assume are product managers, and they're really kind of doing their product managed thing, and in weird ways. But we've seen. Us at Circle CI, we've seen over the last 3+ years, we've been publishing some research around what it means to be a high-performing team. We've reviewed over 300 million workflows, over 40,000 organizations, almost 300,000 projects, all anonymous, and be able to kind of identify what are kind of specific CI/CD benchmarks that identify what a high-performing team is. Let's go through those real quickly, and we'll finish. So, throughput, that's the average number of workflow runs per day, merged on any pull request. Like that's that benchmark. You're not the Netflixes that do it 1,000 times a day, unless you happen to be from Netflix, then hi. Duration, like the average length of time for a workflow to run, that should be 10 minutes or less. And that, is going to change based on the company and based on what you're actually building, but it's a good target to look for. Mean time to recovery from any failure should be under 1 hour. Your success rate should be 90% or better on the default branch. Pause real quickly here and say, like, you should not be measuring success rate on your development branches, because those are development. They're supposed to break. It's supposed to not be, you're supposed to have low success rate on that, because that's where innovation happens. Once that works, move it to your production branches, your kind of default branch. That's where you should be 90% or better. All right, so the full report I talked about just right there, you can find that. Highly recommend checking that out. It's the State of Software Delivery Report. Talks about high-performing teams, what it means, how it takes to get there, and you can help your business or even your small team kind of just understand what it means to really be high-performing and maybe be like those product managers on a stick, or whatever they call it. I don't know what that was. All right, so thank you. You can follow me on all of the things. And the last kind of thoughts I have, trans rights are human rights, Black Lives Matter, and abortion is healthcare. Thank you.